Hello and welcome to this module of this course on Apache CloudStack. In this module, we will introduce you to Apache CloudStack. We will go over its history in brief, speak about the core components and key concepts and terminology associated with Apache CloudStack. This module forms the foundation for the upcoming modules where we will start to implement our own cloud environment using Apache CloudStack. Before we talk about Apache CloudStack, let's quickly try to understand the basics of cloud computing. Traditional methods of hosting and deploying IT infrastructure meant we had to deploy monolithic data centers and physical servers. The lead time for this heavy infrastructure deployment was few days to few weeks. It needed large amount of capital spending upfront. This model often led to energy wastage, low utilization, and high efforts for the administration of hardware servers. It was rather difficult to scale these operations very quickly, whether it was to expand the operation to meet growing demand or to shrink operations due to reasons like seasonality. Cloud is a generic term used for a platform that provides hosted services over a network. At the core of cloud computing is hardware virtualization. Because of this, cloud infrastructure can provide us access to shared pool of computing resources which could be rented or leased on on-demand basis. Some of the main benefits and drivers behind cloud computing are: cloud computing allows companies to avoid upfront infrastructure costs and focus on projects that differentiate their services and products. In the recent years, this has enabled technology startups to invent and come up with innovative technologies and products without worrying about spending a lot on upfront fixed infrastructure. Cloud computing allows enterprises to get their applications up and running faster with improved manageability and less maintenance. Cloud computing enables us to rapidly adjust resources to meet fluctuating and unpredictable business demand. Major cloud providers are vastly trying to use renewable energy sources to run their data centers, and they are also coming up with more efficient data center designs to reduce energy consumptions per unit of computing resource. This obviously has tremendous advantages for the environment. Since cloud providers can manage their data centers more efficiently and cheaply, these savings can be passed on to the cloud consumers. The availability of high-capacity networks, low-cost computers, and storage devices, as well as the widespread adoption of hardware virtualization, service-oriented architecture, and atomic utility computing have led to a growth in cloud computing. Companies can scale up as computing needs increase and then scale down again as demands decrease. Cloud computing has become a highly demanded service or utility due to the advantages of high computing power, cheap cost of service, high performance, scalability, accessibility, as well as availability. Some cloud vendors are experiencing growth rates of 50% year over year. To learn more about cloud computing and services provided by the cloud providers, please check out some of our other top-rated courses. Cloud computing can be deployed in multiple configurations. The most popular configuration is, of course, the public cloud. These cloud services are provided by public cloud provider companies like Amazon, Microsoft, Google, Rackspace, and so on. Any individual or company can pay appropriate fee and buy the required services from these public cloud providers. The services are isolated for the individual customer so that they do not interfere with other customers' data or computing resources. But the consumers of the cloud do not have any control over the underlying infrastructure and hardware of the cloud. When companies need more control over their infrastructure, they deploy shareable IT infrastructure in their private data centers. This provides the facility and convenience of a cloud company to all the consumers within the company, at the same time giving more control to the company over their resources. This is called private clouds. But in many situations, companies need to adopt a hybrid approach where they make use of both public and private cloud infrastructure. These two separate segments are joined via secure network links, and the IT resources in both public and private clouds can talk to each other. This configuration is called hybrid cloud. Cloud computing services are typically provided in three different models. Infrastructure as a service. This is the most basic cloud service model, and under this model, the cloud provider offers computers, physical, and more often virtual machines and other resources. IaaS refers to online services that abstract the user from the details of infrastructure like physical computing resources, location, data partitioning, scaling, security, backup, etc. Platform as a service. PaaS offers a development environment to the application developers. In this model, the cloud provider typically develops toolkits and standards for development and channels for distribution and payment. In the PaaS model, cloud providers deliver a computing platform, typically including operating system, programming language execution environment, databases, web servers, etc. Some examples of PaaS are AWS Beanstalk, Azure Web Sites, etc. And software as a service, SaaS. In this model, users gain access to application software and databases. Cloud providers manage the infrastructure and platforms that run the application. SaaS is sometimes referred to as on-demand software and is usually priced on a pay-per-use basis or using a subscription fee. Some examples of SaaS are Google Apps, Microsoft Office 365, etc. In this course, we will focus on infrastructure as a service or IaaS and Apache CloudStack. So which option should you go with? Well, in most cases, a public cloud provider is a good option because it allows you to get started very quickly and without any capital expenditure. But if you want to deploy a private or hybrid cloud infrastructure, or say you want to start a company which provides public cloud infrastructure, then you will need to understand how to deploy these types of environments. That is exactly what Apache CloudStack provides. You can use CloudStack to build a public, private, or hybrid cloud environment. Apache CloudStack enables you to implement cloud services and combine disparate hardware resources and manage them as a single cloud infrastructure platform. So what exactly is Apache CloudStack? What is it used for and how can we implement it? Apache CloudStack is a top-level project of the Apache Software Foundation. Apache CloudStack is an open source infrastructure as a service platform that manages and orchestrates pools of storage, network, and computer resources to build a public or private IaaS compute cloud. Apache CloudStack supports all popular hypervisors for virtualization such as KVM, VMware vSphere, XenServer, Hyper-V, LXC, and so on. It could be used to deploy and manage a public or private IaaS compute cloud environment. Apache CloudStack is written in Java and includes an API and a web GUI that allows you to organize and manage the virtual machines as well as create virtual machine templates. Let's quickly review the history of Apache CloudStack and how it came into existence. The CloudStack project began in 2008 as a startup project, and its first incarnation was known as VMOps. The startup company eventually changed its name to Cloud.com and it released much of the source to CloudStack in May 2010 under the general public license. Cloud.com was purchased in July 2011 by Citrix, and Citrix released CloudStack 3.0 in early 2012. In April 2012, Citrix submitted CloudStack to the Apache incubator. Apache CloudStack graduated from the incubator in March 2013, and the first major release, version 4, was released on March 25, 2013. Apache CloudStack is a mature and feature-rich framework, and it enjoys the support of many well-known names in the technology world. In July 2012, a provider of managed hosting services and data centers for information technology services called DataPipe launched the largest international public cloud to be built on CloudStack. This included 6 data centers in Britain, USA, and Asia. Among its notable users are Apple, Zynga, Nokia, Huawei, Bell Canada, China Telecom, Taiwan Mobile, Dell, and many more. Now we know Apache CloudStack users include many major service providers who run CloudStack and offer public cloud services. On the other hand, we also have users and corporations using CloudStack to build their own private cloud instances. This translates to a vast variety of job opportunities for individuals with knowledge of CloudStack. Such professionals are in high demand and are given outstanding opportunities to work with this software and professionally rise with these influential organizations whilst working with them. Professionals with knowledge and experience in CloudStack are in high demand within startups and large enterprises alike. As the demand increases, the salaries and consulting rates for CloudStack opportunities are also rising. Apache CloudStack has a lot of neat features and benefits. Almost too many to list here, but let's review some of the key features. CloudStack provides a feature-rich out-of-the-box user interface implemented on top of the CloudStack API to manage the cloud infrastructure. It is a fully AJAX-based solution compatible with most of the latest browsers and can also be easily integrated within your existing portal. CloudStack provides a very powerful and easy to build upon API. We can use these APIs to easily build, integrate, and use CloudStack. The CloudStack API is well documented and extensible. CloudStack also includes support for the Amazon AWS EC2 and AWS S3 APIs. CloudStack is a very powerful IaaS cloud management framework. It completely automates the distribution of compute, network, and storage resources across the physical infrastructure while adhering to defined policies on load balancing, data security, and compliance. CloudStack is secure and is built upon open architecture. It supports multiple hypervisors. It can integrate with other cloud frameworks like OpenStack, Amazon S3, etc. With all this and much more included out of the box, it should not be a surprise why Apache CloudStack is so popular amongst many companies and personal preference of many professionals. Let's get technical now and answer some key questions about Apache CloudStack. How does Apache CloudStack work? How can we install Apache CloudStack? And what are the key terms and concepts related to Apache CloudStack? Generally speaking, a CloudStack environment consists of a hierarchical structure that enables it to manage thousands of physical servers, all from a single management interface. The minimum installation consists of one machine that runs as a CloudStack management server and another machine that acts like cloud infrastructure. As you can see, in this case, we have a very simple infrastructure consisting of machine 1 acting as the management server and machine 2 running the hypervisor software. So essentially, for deploying an Apache CloudStack instance, you need to first set up a management server and then specify the resources that need to be managed. The management server typically runs on a dedicated physical or virtual machine. It controls the allocation of virtual machines to hosts and assigns storage and IP addresses and other resources to the virtual machines launched within the cloud. The management server runs in an Apache Tomcat container and requires a MySQL database for persistence. Let's explore Apache CloudStack infrastructure further. When it comes to the cloud infrastructure, there are certain resources that need to be managed by the management server. As you can see, the resources that are managed within the cloud infrastructure include a region, a zone, a pod, a cluster, primary storage, and a secondary storage. We will go over these terms and understand what they exactly mean in subsequent lectures. Next, let's review some key components or terminology related to Apache CloudStack, which we just talked about. These are essential terms which you will need to understand before we dive into the installation and configuration demos in the upcoming sessions. The first core concept we need to understand is the region. A region is the largest organizational unit within Apache CloudStack deployment. You can increase the reliability of the cloud instance by grouping resources into multiple geographical regions. A region is made up of several zones, where each zone is equivalent to a data center. Each region is controlled by its own cluster of management servers running in one of the zones. Using regions, you can provide fault tolerance and disaster recovery in the Apache CloudStack environment. The next level down from the region are the zones. A zone is generally equivalent to one data center. A zone consists of one or more pods and secondary storage. It is the second largest organizational unit within Apache CloudStack deployment. Zones can be private or public. Private zones are reserved for a specific region, whereas public zones are visible to the other users and any user can create a guest in that zone. Each zone consists of one or more pods, and each pod contains one or more clusters of hosts and one or more primary storage servers. A zone may contain one or more primary storage servers, which are shared by all the pods in the zone. Also, it includes a secondary storage, which is shared by all the pods in the zone. The benefit of organizing infrastructure into zones is to provide physical isolation and redundancy. Going further deep into the deployment hierarchy, each zone consists of one or more pods, which consists of a collection of hardware resources configured to form clusters. Typically, a pod is a rack containing one or more clusters, and a layer 2 switch architecture which is shared by all the clusters in that pod. End users are not aware of or have any visibility of pods. A pod often represents a single rack, and hosts in the same pod are in the same subnet. Pods contain one or more primary storage servers. A cluster is a group of identical hosts running on a common hypervisor. For example, a cluster could be a Xen server pool, a set of KVM servers, or VMware cluster pre-configured in vCenter. Clusters are contained within pods, and pods are contained within zones. Size of the cluster is limited by the underlying hypervisor, meaning more resources you allocate to the hypervisor, the bigger the cluster could be. Each cluster consists of a dedicated primary storage device, which is where the virtual machine instances are hosted. Apache CloudStack allows you to create multiple clusters in a cloud deployment.